All right, so we're going to bring this first term down. So that's a 3. Negative 5 times 3 should give times a negative 5 is going to be positive. Negative times a negative is positive. So I believe that would be 140. Then we add 140 plus 0 is just 140. 140 times negative 5 should give us negative 700. Negative 700 plus negative 12 is negative 712. Negative 712 times negative 5. Wow, we're getting some big numbers here. But that should be positive 3,560. Now we add that to our negative 14, and we should get 3,546. Whew. All right, now I always like to put that last number in our box to remember that that is your remainder. And now let's write our final answer. So remember, 1 less degree of x. So instead of x to the 4th, we now only have x to the 3rd. So I have 3x to the 3rd minus 28x squared plus 140x minus 712 plus 3,546 over, don't forget to put your remainder over what we divided by. So that x plus 5. X plus 5. Whew. That was a good one. That was hard. All right, in this next part, we are going to be finding the x-intercepts or the zeros, okay, or also called the solutions. So x-intercepts, zeros, and solutions are all the same thing. All right, so now we are going to be solving. Be sure your answers are in the form of x equals a number. All right. So the first thing we're going to do, we're going to make f of x equals 0. And then we're going to factor appropriately and set each factor equal to 0. All right, but what does that look like? Well, first off, in this problem, you'll notice this is a 2nd degree. So that means it's going to have 2 solutions. So your solutions are always going to be equal to the degree value. All right. So in this case, we're going to set f of x equal to 0. Okay. Or I might just write it on the other side. All right. And now we're going to factor. All right. And when I factor, I teach the x method. So we multiply to the top, add to the bottom. We always multiply to a times c, and then we add to our b value. All right. So if we look at this problem here, this is really 1x. So our a value is 1, our b value is negative 11, and our c value is 30. So a times c is 1 times 30. So we're multiplying to 30, and we're adding to that negative 11. So I like to make a little t-chart of my factors of 30. So you could do 1 times 30, 2 times 15, 3 times 10, 5 times 6. All right, now we want to look at what pair could add to negative 11. So I'm like, oh, 5 plus 6 is 11. But remember, you want negative 11. So maybe I can make this negative 5 and negative 6, because negative 5 times negative 6 is positive 30. And when I add them together, I'll get negative 11. And the last thing we have to do is just put them both over our a value, which is 1. And now we always read them bottom to top. All right, so this would be 1x minus 5 and 1x minus 6. Now, do you have to say 1x in this problem? No, we don't have to. We could just say x minus 5, x minus 6. But remember, we have to set these both equal to 0. So x minus 5 is equal to 0, and x minus 6 is equal to 0. Add 5 to both sides. X is equal to 5. Add 6 to both sides. X is equal to 6. All right, so for this one, I got my solutions. X is equal to 5 and 6. All right, so that would be how we would factor those ones there. All right, let's try another one. Solve by factoring. Okay, notice this one is now to the 4th and 2nd power. All right, don't worry, we still factor it the exact same way. All right, just at the very end, instead of having x minus 5, x minus 6, we would make it x squared. All right, so let's go ahead and factor these ones here. We're going to multiply and add, multiply to 1 times negative 40. So we want to multiply to negative 40. We want to add to positive 6. So let's list out some factors of 40. 1 times 40, 2 times 20, 4 times 10. Ooh, we could use 4 times 10, because if you subtract them, that would give you 6. All right, so let's put 10 and 4. Well, one of these has to be negative. Notice we want to add to a positive 6. So I'm going to make this 4 negative, because then it stays positive 6. All right, so then I can say, okay, we have x plus 10, x minus 4 equals 0. Okay, so x plus 10 equals 0. Whoops, I forgot to square them. Don't forget, it's to the 4th and 2nd power, so we had to square them in this one. All right, so we have x squared plus 10 is equal to 0, and x squared minus 4 is equal to 0. Subtract 10 on each side. X squared is equal to negative 10. And add 4 on each side. X squared is equal to 4. So now I can square root, because the square root cancels out this squared. So if I do it on one side, I got to do it on the other side. So I get x is equal. As soon as you take that square root, you have 2 answers, a positive and a negative. So we usually just write positive, negative, and then the square root of 4 would be 2. All right, over here, it's a little bit trickier. We still want to take the square root. So I get x by itself, and then we have to do the square root of this side. All right, the square root of a negative number, though, remember, is that imaginary, okay? Or we write I. We still have plus or minus, and then we'll just leave it root 10, because root 10 is not a nice number. All right, but then you might be thinking, wait a second, Mr. Huber, this one only has 2 answers. You said we have the number of solutions as the highest degree. Well, this actually does have 4 solutions. It's going to have positive I root 10, negative I root 10, positive 2, and negative 2. So these would be your 4 solutions for that number 4. All right, on to number 5. This one here, we have f of x is equal to this polynomial here, which you'll notice has 4 terms. Remember from our summative number 1, when we have 4 terms when we're factoring, remember we try that factor by grouping. So let's go ahead and let's split this. Let's look for a GCF in this first half. I think we could pull out an x squared so that this is now 2x minus 5. All right, and then the second half, let's try to pull out maybe 5. So 5 times 2 is 10, and then 5 times 5 is 25. And then you'll notice, sure enough, these are both 2x minus 5. So we did it correctly. So now I write that 2x minus 5 times, and now I write these outside too. All right, so we have x squared and then plus 5 because it's a positive 5. All right, and then we would have to set this equal to 0. So now let's just set both of those equal to 0. So I have 2x minus 5 is equal to 0. And you have x squared plus 5 is equal to 0. So we would want to add 5 to each side. So I get 2x is equal to 5, and then let's just divide each side by 2. So I got x is equal to 5 halves, or 5 over 2. And on this side, subtract 5 on either side. So I get x squared is equal to negative 5. Now remember, to get rid of that squared, we have to take the square root of both sides. All right, so I get x equals positive or negative as soon as you take a square root. All right, it's of a negative number though, so that's when we have that imaginary or that I, and then we just leave it root 5. All right, so notice this one was to the 3rd degree, and we have one answer. And then this is a positive I root 5 and a negative I root 5. So this is really 2 answers. So we have 3 answers total because it's degree 3. All right, moving right along on to target number 5. I can find x-intercepts of a polynomial function. All right, so in these ones, we're now going to combine the 2 things that we just did. We're going to combine synthetic division with our factoring. All right, so strap in. So reminders on finding zeros. Do not change the sign of the x value. Okay, do not change the sign. You will use synthetic division first to make the polynomial smaller. So we're going to use synthetic division. You will then take the remaining polynomial and factor. So it's the 2 things that we just talked about. First, we're going to do synthetic division like we did in the first section. Then we're going to factor like we did in the second section. All right, so this says, given that x is equal to 4, so we actually don't have to set this equal to 0. Instead, we're just going to write this 4 on the outside of our synthetic division hut. All right, next, let's write all of our leading coefficients. So you have 1x to the 3rd, you have negative 2x squared, negative 11x, positive 12. Notice we didn't skip any. It went x to the 3rd, x to the 2nd, x to the 1st, and then just your constant. All right, bring your first number down, multiply. 4 times 1 is 4, and then add. 4 plus negative 2 is 2. 4 times 2 is 8. 8 plus negative 11 should give us negative 3. Negative 3 times 4 is negative 12. And notice we have a 0 remainder. Well, that's because it told us 4 is a 0. If it's a 0, it's not going to have a remainder. So if you ever get a remainder, then you know you did it wrong and you have to go back and check your work. Okay? So now we have one less degree, so it should just be x to the second instead of to the third. So I have 1x to the second, or just x to the second, plus 2x minus 3. And remember, we want to set this equal to 0 because we're going to factor it. All right, so in this case, we want to multiply to -3 and add to 2. All right, so let's think of some factors of 3. 1 times 3, and that's it. All right, so that one's pretty easy. We just know it's 1 and 3, but one of these has to be negative. See how this is positive? So I'm going to make this smaller number negative. I'll make this a -1. All right, so then I have x minus 1, x plus 3 equals 0. So x minus 1 is equal to 0, and x plus 3 is equal to 0. And now we solve. So our solutions are x equals 1 and -3. Okay. But wait a second, remember it's x to the third, so shouldn't there be 3 solutions? Well, it gave you this first solution. So we could also write 4 in there as well. So that's all 3 of our solutions to that one. All right, let's try another one. -3 on the outside of our synthetic division hut, because x is equal to -3, is a 0. All right, so we should not get a remainder. All right, notice it goes x to the third, x to the second, x, and then a constant. Sounds good. All right, we write the leading coefficients. So we have 1x to the third, -8x squared, -23, and then 30. Bring down your first number here. Multiply -3 times 1 is -3. Add -8 plus -3 should give us -11. Then we multiply again. That should give us +33. Then we add, so that would give us 10. And then we multiply, we get -30 for a remainder of 0, which means we did it right because -3 is a 0. So now we're left with x squared minus 11x plus 10 equals 0. And now we want to factor. Multiply to 10, add to -11. So let's think of some factors of 10. 1 times 10, 2 times 5, that's about it. All right, so I'm thinking 1 times 10, but watch out, because we're going to have to make both of them negative, because negative times negative is a +10, and then -10 plus -1 is -11. All right, so we have x minus 10, x minus 1 is equal to 0, and now we just have to set them both equal to 0. So I got x equals 1 and 10. And don't forget about our -3. So these would be our 3 solutions to this one. Okay, now if no x value is given, then you have to use your calculator to graph and pick one of those x-intercepts, and then you just do the same thing. All right, so we look at the x-intercepts. All right, so if you're having trouble on these problems, I like an app called Desmos. All right, so that app looks like this here in the green. all right, we would just plug our polynomial in. All right, so in this case, we would plug in just this part right here. So x to the third minus x squared, x to the third minus x squared plus 49x minus 49. Okay, now you can kind of change your window around a little bit so that you can see it a little better. Okay, but we are interested in this x-intercept. So we find an x-intercept. So we have x is 1. X equals 1. Now it's just like this problem right up here. So we put 1 on the outside of our synthetic division hut. We have 1x to the third, negative 1x squared, 49, and then negative 49. Bring it down, multiply. Add them together, multiply. Add them together, multiply. Add them together, and sure enough, we got 0, which is good because it's an x-intercept or a 0, so we should have gotten no remainder. So now I'm left with x squared plus 0x plus 49. Now we don't actually have to write this 0x if we don't want to. All right. So now we have x squared plus 49 is equal to 0. All right, and we can actually factor this one because we actually don't need to factor this one because we can just solve it. So I can subtract 49 on either side. So I get x squared is equal to negative 49. And now we want the square root to cancel out that squared. So I get x is equal to plus or minus. It's the square root of a negative. So remember, that's imaginary, I. And the square root of 49 is 7. So you either write it like that, but usually you write your 7 and then your I. All right, so in this one, we would have x is equal to 1, 7i, and negative 7i, which is why on the graph, we only see one x-intercept when really there should be 3 of them. We only see 1 because these 2 are imaginary. Okay, that's why we needed this one from the calculator.